Welcome to today's lesson, section 9.1a, Vectors in Two Dimensions, part 2. So here we're just a continuation from part 1. So we're going to start with algebraic operations on vectors. So here if you have two vectors, vector u and vector v, if you add your two vectors to each other, then that means your values in the first part, so your a sub 1 and a sub 2, add to each other, and your b sub 1 and b sub 2 add to each other. Okay, just like for subtraction, you're going to subtract your first values and you subtract your second values. And then also if I multiply by a scalar, so looking at the value of c is a scalar number, so like if I had 2 times the vector u, then that means I distribute that number to both of the values inside. Okay? So here, an example is that they want us to take the vectors u, which is 1, 5, and the vector v of negative 3, 4, and they want us to do several different operations. So if I was to add vector u and vector v to each other, that means 1, 5 plus negative 3, 4. So 1 plus a negative 3, 5 plus 4. That should give me negative 2, 9. So that would be my new vector of addition. If I did the subtraction one, same thing, 1, 5, subtract negative 3, 4. So 1 minus a negative 3, don't forget the doubles, because that makes it plus, and then 5 minus 4. So adding here makes that a 4, and then 5 minus 4 gives me 1. Okay, so there's your subtraction of the two vectors. And then here we're using our scalars, so if I multiply my vector of u by a scalar of 2, then that means it's 2 times 1, 5. So then 2 times 1 plus, oops, not plus, 5 times 2. I'll switch that around real quick. 2. Okay, so that gives me 2, 10. Okay. Do the same thing for vector v. Just multiplying it by negative 3. So negative 3 times negative 3 is 9. And negative 3 times 4 is negative 12. Okay, and then this last one we're combining two of our operations, so scalars and subtraction. So okay. So once I plug those in, that new vector is going to be 4 minus 20 minus negative 9, 12. And then now I got to subtract, so 4 minus a negative 9. That makes it positive 20 minus 12. So that gives me 13 and 8. Okay, so there's all our little operations that we're doing. Okay, next thing is talking about properties that you have with your addition and your multiplication. So if I'm adding vectors, remember vectors are symmetric, just like if I was regular numbers, like 2 plus 3 is the same thing as 3 plus 2. So doing the same thing with vectors, so vector u plus vector v is the same thing as adding v plus vector u. Also, the associative property works. That's the second one here. So if I just move my parentheses around and add two vectors first, and then change my parentheses in the second one to add two different ones first, then I'm still going to get the same solution. Taking your vector and adding it to the 0 vector, which is just 0, is equal to your original vector, just like 2 plus 0 is 2. And then also, if you have a vector and you add it to the opposite of its vector, so the negative of it, then that means you get this 0 vector. Okay? A length of a vector is the same thing as if I multiply by a scalar times your vector, but that's also the same thing, and that's the absolute value of it. It's the same thing if I take out the scalar and do the absolute value of the vector and the scalar individually to find the length. Those are the same. Multiplication of a scalar. So distributive property works as well. So if I multiply a scalar to the addition of two vectors, then I can distribute the scalar to both. If I have an addition of two scalars and I'm multiplying that by a vector, then that also works as well. Okay, but then I'm distributing the vector instead of the scalar, so then you get c times the vector of u plus d times the vector of u. Then also, with multiplication, commutative or associative property works as well. So you can switch around the parentheses around even if they're just scalars with your unit vectors. So those can move around. And then also 1 times your vector is just your vector, 0 times your vector is 0, and a scalar times 0, which is something that we should be used to. Scalar is just a regular number. Times 0 is still 0. So, and remember, 0 is the 0 vector. So that means that when I write that, it's 0 comma 0, but I can just write 0 for it. Okay? Now we can rewrite vectors in terms of different forms, so in terms of I and j. So if a vector a comma b can be expressed in terms of a and j, or sorry, I and j, for this, it'll look like this. So we'll write a times I plus b times j. Okay, that's how we'll notate it. So the I is your kind of like your x value, and your j is kind of like your y value. And so it's kind of like a placeholder where it tells you this value attached to me is correlating to the x-axis, and the one for the j is saying it's correlating to the y-axis. Now also, since you have vectors, you can also express vectors as unit vectors, and there are vectors of length of 1. If you go back to finding the magnitude in our last video, if I took the square of a plus the square of b and then square rooted it, I would get 1 for each of these. So i's unit vector would look like 1 comma 0, and j's unit vector would look like 0 comma 1. Or you just write kind of like that, which reduces to just I. Same thing for this one. If you had 0I plus 1j, it would just reduce to j. So that's why we have them just equal to I and j. Okay. So here, if I want to write the vector u, 9 comma -7, in terms of I and j, that means that my 9 is my a value, so I attach it to the I, and then the 7 is attached to the j value. So it's 9I minus 7j. Okay, and then our next example here is if vector u is equal to 3I plus 2j, and vector v is equal to 8I minus 5j, we want to be able to write the new vector 2u plus 5v in terms of I and j. So that means that the same operations apply. So if I do 2 times my u vector, which is 3I plus 2j, and then plus 5 times my v vector, which is 8I minus 5j, you can distribute like we talked about. So 2 times 3I gives me 6I. 2 times 2j gives me 4j. 5 times 8 is 40I. And 5 times negative 5j is negative 25j. Okay, so then I have like terms here with my i's, and then I have like terms with my j's. So 6i plus 40i is 46i, and then 4j minus 25j is negative 21j. So then this would be my vector that would express those two in this expression together. Okay. Now in class I have some practice examples to help us learn how to graph these correctly. So we're going to graph in class together. So don't worry about like whether we're going to do that or not, but we'll do that together. Okay? Have fun.